Hello everyone. So we are going to start the season 1 in Python episode 9. In this episode, we are going to learn what is a refinement and also the software engineering, which is one of the most important area of computer science. So let's start with the screen sharing with my iPad. So go back to here. Yes, so this is my screen, then a little bit up. Okay, so let me ask a question to you. So when you have the exam, like the midterm exam or a final exam, so how do you prepare the exam? So for example, you have the 3 subjects, like for example, you have the English, and also you have math, and you have science. So you are going to prepare the 3 subjects for midterm and final exam like that. Then, so usually what I'm doing is when I was a student, so I prepare for the exam, like I make the plan, the schedule, the full study, then I did my study like that. At that time, so my plan is like that. For example, I'm going to finish the all of English. So I spend all the time, the first, for example, the 3 days. So 3 days for the English, study English. Then the next, after I finish the English, then I'm going to start the math. So spend the 2 days of math like this. Once I finish all the math study, then I can start for the science. So science for 3 days like this. This is usually what I was doing to prepare for the exam. So once I finish the English, then move to the math. Then after I finish the math, I move to the science. Then I can do the final exam at this moment. So this is a task done like that. This is one the approach to prepare the exam. Another approach, my friend, like this. So if you have the 3 subjects like the before, if you have the English and you have the math and also you have the science, then what my friend did to prepare for the final exam, what he did is he usually start the English first, but only 1 day. Okay? Then he changed the subject the next day to the math and change it to the science the 3rd day. So like 1 day for English, 1 day math, then 1 day science, then go back to the English, then study English 1 day, then for science another day, and the next day study the science like that, and go back to English again. So go back to English, then he finished the math, so he can do the science like that. So science. So once he finished the science, then he can start for the exam. Then task is done. So which way do you like? So what types of the schedule? Usually you plan for the preparation of the final exam. It's up to you. We cannot say which one is better than the other. Like the first approach is better. The first approach is better. Or, or the second approach is better. What do you like? So it depends on the preference. So this is the 2 most popular approach. One is like this one is like it's called the top-down or the waterfall approach. So as you can see, once you finish the one of the tasks, then move on to the another task. Once you complete the math, then move on the next task. Finally, you can complete the entire project. As you can see, it looks like the waterfall. Waterfall, like this is kind of waterfall, the approach. Another one is this one. So this is kind of the iterative approach. Iterative means, so if you start only finish the certain part of the task, English, then the math and science. So you did this part, then go back to the English again. Then the study, this, then go back to the English again. Then eventually you are going to finish the task. So this approach is called the iterative. Iteration means it's repeated. You are going to repeat. Or sometimes it's called the spiral development. If you see on this view, so for example, so you have math, so you have the English, you have science. So you are going to start from the English and science and math, English, science, math, English, like this. It's like the spiral way. So you are going to finish the certain task spiral way. So if you think about it, it's not only for the study plan. So no matter what types of task or what types of the plan you are doing, so most of the task, either the first task like the waterfall approach, or the second one, spiral approach. So in computer science, when you develop the project, when you are doing the coding job, so there are two main ways. So one is, okay, oops. Let me go back to here. Yes. Oops. Once again. So two approach. One is, so you complete a certain part, then move on to next, and move on to next. So this approach. So this is called the top-down approach. Top-down. And another approach is like this. So we are going to complete a certain part of a task, then move on to the next task and solve it little bit, and then move on to the next task and solve the little bit. Then go back to the first task again and again. So this is called the iterative approach when you develop the program. Or this is called the spiral development. This kind of the thing is called we are going to call, is called software engineering. So software engineering is very popular, but it's for the hardware engineering, like the mechanical engineering, electrical engineering, and something biomedical engineering. Similarly, computer science has the engineering, which is called the software engineering. Software engineering is now very, very important, the area of computer science. That deal with what? It's the management of developing software. How to develop the software? There are different approach, different technique. So in the picture, there are two approach. One is waterfall, another one is the spiral. Or the different name is waterfall is called the top-down approach, or the spiral is called the iterative approach. We cannot say which one is better than the other, but some of the people like the top-down approach, the other likes the iterative approach. And also certain project need only top-down, so spiral doesn't work. On the other hand, the other project need iterative spiral approach. Review again and again, and then eventually the project will be better. At the time, the waterfall top-down approach is not working. So who is in charge of that? Usually the project manager. So you heard about the project manager, or sometimes it's called the PM. So PM is the person who is in charge, who is a plan, who decide what kind of process is better to solve the problem. Then the people, developer or software engineer is following the way of developing. So this is very important to speed up or to make the better quality of the software. So today I'm going to introduce among them we mostly use, not always, but we like the top-down approach. So even I like such a top-down approach. So I'm going to introduce such a top-down approach when you develop the software. In other words, when you code, when you are doing the programming, when you are using program language, so you can use such a top-down approach. So we will see how we can use such a top-down approach to solve very complicated problem. Okay, so let's go back to the slide. Okay, so this is our Enium Python, the season 1, the episode 9. So we are going to start with today's episode. I already introduced the two main approach of solving the problem. So this is called the software engineer. So as I said, the software engineering has the two main parts. One is the waterfall. Sometimes it's called the top-down. Another one is a spider. Sometimes it's called the iterative. They are the same thing. This one is same, and this one is the same. Then this is the one example of the top-down, the waterfall approach. So for example, if you can see the waterfall design. So first we are going to start with the requirement. What is the requirement of this project? And what is the requirement of the program? So first define such a requirement. Then based on such a identified requirement, we are going to design the software, or sometimes it's called the software architecture, or this kind of blueprint, okay? It's a plan, outline of your development. Then we are going to start the implementation. So implementation, the coding itself is just a part of the entire software engineering development. Then once you finish the developing, then we can verify whether the program is working well or not. Then even after you finish everything, it's not done yet. The people are using your software. Then they sometimes find something problem. So you need to debug. Or they ask, why don't you modify and enhance the function? Then you are going to maintain. So this is the top-down approach, one by one, or sometimes it's called the waterfall approach. Most popular, the software engineer approach. So another one is the spider approach. As you can see here, the spider approach is starting from the for better. So let me change it. This one. So then you can see very clearly the software, the engineering, the spider approach. You can start from the development. So you are going to identify the very basic problem, okay? Then you are going to implement, test, and see. Then review. In this stage, before you move into the first the process, the review it. So based on the review, you modify certain the requirement and the object. Then identify the problem and solve it, and the development again, and so on. And so on. Eventually, it will be the final product. So we can repeat and repeat certain the process until we have the final product. Okay, so this is the spiral approach, or this is called the iterative, because we are going to repeat the same process again and again until we finish it. So this is today's problem. The rest of time, we are going to solve the problem. So this is called the beeper, the collecting cattle problem. Let me explain the first. So cattle is the moving left, west to east, okay? So from here to here. So that is the first thing. Then when a cattle is moving the west to east, if there is a cattle, so cattle is actually set up along the street. This is an avenue, right? It's a column. As a column, the beeper is like this. Beeper is like this, and beeper is like this. So sometimes there is no beeper tower, but if there is, it's like sometimes two, sometimes one, sometimes very high. It can be almost, it's reached to the top, like this. But this time there is no, okay? So what a cattle is doing is, the requirement is cattle need to collect the beeper. How? So this is the way. So first start from the 1, 1, the location here. And there's a beeper. So any beeper upward, pick up them. Then here, turn around, and the cattle is not moving this way. They're just moving back, okay, this way. Then the first column are collected. Then move on the second column, second avenue. Then if there is a beeper, and pick beeper, all the beeper along the avenue. Then here, turn around and move down. Okay, then going on, the next column, next avenue, and there is a beeper. So we are going to collect the old beeper, then going back to the first street. Always the first street. Do not move the jump this way. Okay, cattle cannot move to this way in this problem, in this task. Cattle always collecting the up, down, and only first the street, the cattle is moving to the east. So same thing like the collector this one, and the move on, collector this one. Very nice. And then the collector this one, and move back. And next, there's no beeper, which means cattle doesn't have to upward and downward. Just to move on to the next. There is a beeper, so up and the turn around, and then the down, move to work, and move on. Okay, so that is collecting the old beeper. That is the first task. Then, once the cattle collect the old beeper, so cattle is going to put beeper, all the beeper, a cattle collected. So like for example, in this case, how many? So if you count all the beeper, it's probably 25 beeper. If you want to, you can count. Yes, definitely it's 25. So 25 beeper will be that you need to put all 25 over here. Okay. So you can put the all beeper. Okay. Then that's the second thing that you need to do. The cattle is collecting first, all the beeper in this way. Then at the end, put beeper everything. Then once the cattle put beeper, all the beeper, then move back to the original position. Where is the original position? It's here. So this is the before you start the program. Once you code, everything is done. Then this is the after your program is done. So this is much more complicated than the previous example. So we have solved a number of the problem before, but this one is much more complicated. So we learned the software engineer. We learned the top-down approach. We learned the spiral approach. We learned the iterative approach. We are going to use the one of them. Do you think what kind of approach is better here? What kind of approach? Why don't you think about the problem and how we can solve the problem? So in this case, if I were you, I'd like to use top-down approach. So first, I'm going to clarify the problem. The problem is like the collect the beeper, put beeper, going back to the original position like that. Then when you collect the beeper, the carrier need to check whether there is a beeper or not, because it's kind of a tower. So it's not possible like this. Without the first beeper, there's no other beeper upward. So you need to check. If there is, then they're going up until no more beeper and going down, collecting, and so on. So it looks like the top, very the big task, then narrow down the specific problem. So we are going to use such a top-down approach to solve this problem today. Okay, so let's move on. So this time, why don't we start with the pie chart? So if you start your project on your pie chart, so episode 9 is there are 2 of them. Why don't you select the beeper collecting carol? Okay? Beeper collecting carol. As usual, this one has the 3 parts: the import and the main, and also the if the name is main, and call the main function like this. So what you're gonna do is you are going to start here. So the first thing is we are going to use the top-down design approach. So let me change the screen. So please start your pie chart and then select the project. So then you can open E09 episode 9, the beeper collecting carol. Okay, so here, very nice. So let's go back to our problem once again. So we understand right now what are the problems then. So in a big picture, so we can just say that there are several tasks a carrier need to do. First thing is, we can say the first part is, so let me move on this. So first part is what? So pick up the old carrier, right? Then second part is what? The put all beeper. So put all the beeper. And third part is what? Back to the original, move back. So this is the third one. So carrier need to complete the 3 main tasks. One is collecting all beeper. Then second is put all beeper collected, right? Third one, back to the original position, the home position. So what we're gonna do is we are going to create the 3 main tasks. So first task is number 1, collecting. Why don't you follow so me, then you can directly code for the problem. So this time you don't have to wait, you don't have to watch, just follow me. The first problem is collecting or the beeper. Okay, I know there is no such a function yet. We are going to create. So this is just a plan design. even though it's not working right now. So collecting all beeper. So let me use the simple name, the collect all beeper. And what will be the second task? Second task is the put all the beeper, drop all beeper. So we are going to drop all the beeper. Then the third one is a back to home. So return home, the function. So what we're gonna do is we are going to eventually create the three functions. So one is collect all beepers. So then we can pass. And the second, drop all beepers, right? Then also pass, because we don't start yet. So once we start define the first big task and move on the next level, like that. Third one, so it's a return home. And also pass. Yes, so this is the first level, top approach. Then what we're gonna do is we are going to solve the problem from this one. So let's collect all beeper. So let's go back to here. So when you collect the beeper, we can also imagine, we can think about the details of collecting beeper. How can you collecting beeper? So we can collect one beeper, one tower of the beeper. Then move on the next one. And collecting all of this. And collecting all of this. So we can do this, the collecting all beeper has number of many times of collecting one tower. So let's start to implement collecting one tower, right? So to collect one tower, so let me change it, the screen into the, oops, let me delete all of this, and then open the iPad also. So how can you collect the beepers in one tower? So we have the beeper, 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 and we have the carol over here. So carol, first, if carol is here, what you're gonna do is first turn left, because the carol should move up. To do that, first we are going to turn left, right? After we turn left, the next one is collect all beeper until when? If there is no more beeper. So second thing is pick all beeper until when? The no more beeper. No more beeper. Okay, so the carol collect all the beeper. Then next thing is turn around, right? Turn around. And then move to word, right? That's good. Move to word. Then, so when the end of the word, carol is facing here, which means it's turn around. So this one, turn left, not turn around, turn left. So 5 steps we can find. So first, so turn left. Okay, then the pick all beeper. Then until when? No more beeper. Then turn around and move toward and turn left. So this is the step by step to collect the one tower. We are going to just convert this step into code. Very simple. So let's go back to the desktop. So the next step is we are going to first collect the one tower. Collect the one tower. Okay, so collect the one tower. So we need to define collect one tower. So collect the one tower has the 5 steps. So if you remember, first turn left. So we can make the caret turn left. It's a T-U-R-N. Okay, every time I mistake. Okay, so that's good. Then after turn left, we need to make another function, collect line of beeper. Yes, so we can collect the one line of beepers. So this is underline, red underline, because it's a new function we need to complete. Then once reach the end light here, so we need to turn around. So for example, once again, so if the caret is reached here, it's no more beeper, then should turn around. So we should have the turn around. However, turn around we implemented last time. It's not given function, we need to define. Okay, then once turn around, then next thing is a move toward. We know what is a move toward. Okay, then final step is turn back to original position. That is turn left. Okay, so very nice. So but we need to complete the several functions we defined, then step down. So it's the top-down approach. We start from the very big task, collecting, drop, move back. So for the collecting, we are doing collecting the beeper. So instead of implementing all the steps, so we segment the job. So if we have the collect one line of beeper, then we can do it again. So we are doing the collect one tower. So collect one tower has the 5 steps. So turn left, collect a line of beeper, turn around, the move toward, turn left. So we know the turnaround. So let's solve the easy one. Turn around. Turn around is how many times turn left? Yes, 2 times. Turn left. And another turn left. So it's done. So we already implemented that one too, right? And what about there's a mistake over here. So T-U-R-N. So T-U-R-N. Okay. And what about the move toward? So move toward we did last time. We can use what? While loop. So move to word. So do you remember move to word? Move. Why? Front, we can use test function. Front is what? Clear. Yes. Front is clear. Then we can make the move. If not clear, which means a block, like this word, then no more move. That's it. So very simple. Okay. Then what we need to do is finally this one, the collect line of beeper. So let's implement the collect the line of beeper, DEF, and collect the line of beeper. So how can we collect the line of beeper? So to collect the line of beeper, so we need to start what? What the statement we can use? We learned a lot the beeper to collect the line of beeper. The caret can pick up, then move, pick up, move, pick up, move, pick up, move. How many times? Do you know the target? No, we don't know. Sometimes high, sometimes 3 times, sometimes 7 times. We don't know. But we know the condition until when. So beeper present. If there is a beeper, then pick up. So we can use what? While loop. So we can use a while loop. So until when? Beeper present. If there is a beeper, then pick beeper. Once pick beeper, we need to do what? We need to what? If front is clear, if front is clear, then we can move, right? So that's it. So then we can move. However, it's not a good idea. Collect line of beepers. So there's a mistake like this. Collect line of beepers. Yes, we need to delete this one. Yes. So it is good idea to test from time to time. So it's kind of we are using spiral approach here. It's all the top-down approach in general, but from time to time, we do better test whether my code is working. My code is collecting 1 tower. We can check the collecting 1 tower. At that time, we don't have to run this one. We can comment and comment. Then run the program. So let's run the program. So we are going to run and run and select the beeper collect the carol. Okay, so here is the carol's work and run program. Collecting and turn around. Yes. So as you can see, the carol is collecting all the beeper on a line. Okay, so this is the perfect. If there is any problem, you can fix that problem. So you don't have to worry about the drop all beeper, return home. It's not done yet. Just collect all beeper. So collect all beeper has the only collect 1 tower. If this one is not working, so you can fix the problem over here. If yes, then we can move on the next one. So we are doing the collect all beeper. It's not done yet. So but we have the function to collect the 1 tower. So how can we collect all the beeper here? So first, carol is here. Carol is here. If there is a beeper, which means we can run what? Collect 1 tower. Yes. Then move on the next one. So if there is a beeper, then collect 1 tower. If there is a beeper, collect the 1 tower. Collect it and move on. If there is a beeper, but there's no beeper, you don't have to run it. Okay, then move. So what we can use? At this time, we can use what? Collect 1 tower with while loop. Very nice. So we are going to use collect 1 tower with while loop. So while what? Front is clear. Front is clear. Okay. Then front is clear. Collect 1 tower. Then move. So if front is clear, then collect collect 1 tower. Let's run the program. We are going to run the program. Let's erase our note. Then run the program. So carol is collecting the beeper. First one, yes, good. And the move, yes, collect. No problem. Collecting all the beeper, yes. Little bit speed up. Little bit speed up. A lot speed up. Yes, perfect. Yes, it's perfect. It's really perfect. What do you think? Actually, there was no beeper over here, so it was okay. But what if there exists tower of beeper here? So collect one tower. Collect the one tower is here, right? So then its front is clear. However, front is not clear. So it out of the while loop. Then end. What if there is a beeper over here? It cannot pick it up, right? So this is the problem. Do you remember this kind of problem before? Yes, this is called fence post problem. So we collect the one tower and move. Collect the one tower, move. Collect the reset, collect the one tower, move. Collect one tower, move. One tower, move. One tower, move. Then after move, front is clear. No, then out. Didn't collect. So we need to collect the one more time. One more time what? The collect one tower. So because of fence post problem, so we need to run the one more time. So let's run the program. You can run with this one. And run the program. So it's probably the same as the previous one. Little bit speed up. Yes. Then actually, if there is the beeper over here, the carrier is collecting them. Okay, so very nice so far. So carrier can collect all the beeper. Okay. Then what is the next task? So the next task is we need to put beeper. So which is the drop or beeper. So we are going to drop our beeper and delete the pass. Then, so how can we drop the old beeper? So we are going to put beeper, put beeper, put beeper until when? Until no more beeper in carol. So do you remember the function? If you cannot remember the function, why don't you go back and find the proper function. That is beepers. You can see over here, beepers in a bag. This one, beepers in a bag. If there's a beeper in a bag, then what is that? The put beeper. Very nice. So let's test. So we are going to run the program. So here the close and then run the program. Yes. So let's see. Little bit speed up. Yes, and put all beeper. It's gonna be 25 beeper. Yes, so far so good. So this is this shows that we complete the first test, collecting all beeper and drop all beeper. Second test. So last one is what? Do you remember that? Last one is the return home. So we are going to solve the last task, return home. Return home is here. So how can make the carol return home? Any idea? It's very easy actually. So why don't you think about? We already have the several function here. So for example, we have the turnaround and the move toward like that. Yes, we are going to use this turnaround and the move toward. So how? First, make the carrot turn around, then the facing west, and the move toward until here. Okay, that's not done yet because first the initial position is facing to east. So we can make the carrot turn around. So let's try. So turn around. Please follow me. Follow my coding. Do not just watch. Then you are able to complete this task with what? Top-down approach. So work. So we create and also turn around. Okay, so that. So let's try. So this time run this. Run the program. Let's see. Okay, so let's a little bit speed up. Very nice. And very nice. And more speed up, faster. Yes, put people and back to home and turn around. Yes, this is done. Our job is done. So, but we are not sure whether this one is really working well. So we are going to change the word. So we have another example is the 2, the episode 9 2. So you can see this one. Run the program. Let's see whether this one is working. Very nice. Little bit speed up. Okay, looks good. And so far so good. And put all people back. This total is also 25. And get back home. Very nice. So our job is done. So why don't you solve the problem on the Python? Okay, so if you are not sure the code, you can go to the beeper collecting carol, and this is the solution of what I explained with the command. Okay, so you can solve the problem. Then several more things. So let me back. So this is what we have done so far. So once again, so to solve the problem, we are going to start the first top task, big picture. So we can find the requirement. So 3 main steps. One is to collect all beeper. and drop all beeper and return home. So who decide? You are going to decide. So this is kind of the approach to solve the problem. When you encounter real big problem, don't try to solve the all at once. Instead, we are going to chop. So 3 main tasks. So I'm going to solve this problem. Then the narrow down. So we are going to start from the collect all beeper, like that. Okay, so collect all beeper. So even when you collect all beeper, the segment the job. So if we can solve the problem of the collect one tower, then we can move, collect another tower, another. So one collect one tower is the main problem, like that. So we can collect one tower, so like this. Then collect one tower has the also number of steps. In this case, the 5 steps. So we are going to define the collector line of beeper like that. So then at this time, you should be careful, such as the precondition and post-condition of the function. Meaning is, so for example, when we get back to the original position, we are going to facing to east. So always the function, the starting and the ending should be the same. So that is the starting and the ending condition should be satisfied with the such a condition. So this is the collect all beeper. So it's if the front is clear, then collect one tower, then move. Then so on until no more the beeper. However, the problem is the last one. So because of what? Fence post problem. So we are going to collect the one more tower. That is the last line. Then the next, so we can do the put beeper, then drop all beeper, then finally return home like this. Very nice. Then we can solve the problem. So when you encounter really big problem, don't try to solve all the problem at once. Instead, you are going to split kind of design. You can draw the diagram, or you can draw the flow chart like that, and then you are going to solve one by one. And even though when you create the function by function, you don't have to wait until the last line of code. Instead, you can test one by one. Then you make sure that your code is running correctly. This is called the unit test. You can test unit by unit. Okay, there are several the things you can keep in mind. One, okay, so first, the good function is sometimes some of them can be the function, sometimes not. For example, move is not function, you don't have to create, but the collector or beeper is. So a good function is should do the action or the one task. So you don't have to combine all of this in one function. Just for example, collect all beeper is doing what? Collecting one tower. The collect all beeper. Then the inside, the front collect one tower is a line of tower. Then the collect line of beeper and the line of beeper. So like that. So group function. When you define refine, this is called the refinement. You are going to specify the task. So eventually, one good function has the one conceptual the task meaning. Okay. Then also another important thing is the name. Even you can name for this one like the A, then you say, but nobody knows what the A means. So meaningful name is very important. At that time, you can use underscore between the word. Tomorrow, not tomorrow, next episode, we are going to see such a naming rule. This is called the snake case. The snake case, the naming rule. So there is another time, it's called the comma. Comma is different. So next episode, we are going to see such a naming rule. So when you create a function, your function name should be meaningful. Also, function, as you can see, is usually how many? the line. It's not too long. It's just the 5, 3 to 5. It's no more than 10. Okay, if your one function is too long, nobody understands. It's boring. And so usually it's a 10 line of code per function is good. And also, as you can see, the indentation is very important. Indentation means what? It's a code block. It's the same boundary. But you can see the nested, like the code block inside the code block. It might be possible. However, if you have the too many code block inside, like the code block inside the code block inside the code block inside the code block, it's too much complicated. How many level? There's no general rule, but the 3 level is good for the program. So there's no strict rule, but in general, so 3 level, so it's enough. So that's the one thing you need to consider. Then we create the turnaround before. We create the what? Turn right and or move toward. So when you create a function, think about the reusable and easy to modify. Later, we may use this one. So that is another idea when you create the function. Okay, the last one, most important. I didn't do that to save the time, but it is very important to give the command using hashtag, like the collect all beepers from carol word, like this. So 1 or 2 line, usually 1 line is enough just before the function to give the comment like this. Just explain, like here, put all beeper at the end, okay? Then return the carol returns home, okay? You can give the more detail, the bottom left corner, like this. So 1 or 2 line is enough. Then the collect 1 tower. So function to collect 1 the column or tower, like this. Then add another one is collecting lines of beeper until no more beeper. Then it's clear. Others can understand that this is turnaround, 90-degree turnaround, degree turn, and the 2 times of the turn left. Then move toward the moving the to the word. Okay. Then it's very nice. So please put such a comment for each function, at least 1 line, not too many. So this is the educational purpose. So for you guys to understand the meaning of the code, sometimes you need to do that, but otherwise 1 or 2 line is enough. Then, so anyone who read your code can easily understand. Also later, when you are using your code, then you don't have to try to figure it out what's the meaning of this. You can quickly understand that. And also sometimes you are using the inline, the comment like here. This is the first task. So this is the second task. This is the third task, like this. So you can use such a command to make the program has the better readability. So this is very important when you start the programming to add the meaning of the function and also with the command, proper command. Thanks so much today. Please try this code. So then you can understand the general process of developing software and the coding habit. Then the next episode will be the last one for the lecture. So we are going to see the variable. So which is the most important part of the programming. Actually, Carol does not use the variable, but I add a variable for your better the programming experience. Then the last episode, we are going to have the kind of competition, the programming, the exercise. Okay, thanks so much for your attending. Then please do your homework by watching this video. Then your programming skill will be improved. Okay, thank you.